Wireless LAN Professionals Podcast, episode 187.
And when we came out with IPA, we quickly realized that we didn't know very much about Wi-Fi, actually. And that's when we had you, Keith. I think that's about the time that we met you and said, hey, Keith, will you come up to Boise and teach us all about Wi-Fi? And so that started our adventure into really learning about Wi-Fi and getting educated. Since then, we've had Robert Bartz come to Boise 3 or 4 times to give us training. And so we have a lot of people now that are CWNA, CWAP, CW SP.
Wireless LAN Professionals is a place to educate, inform, encourage, and entertain those involved in wireless LANs. This Wireless LAN Professionals podcast is an audio manifestation of these goals. Our host is a wireless LAN veteran, consultant, designer, and teacher, Keith Parsons. And now, the podcast for wireless LAN professionals by wireless LAN professionals.
Welcome back to Wireless LAN Professionals podcast. This is Keith Parsons, and today I have with me Ryan Woodings. Ryan, how are you doing?
I'm doing great. Thanks, Keith.
Are you still called Chief Geek?
Yes, I am.
Oh, good title. I like when companies have really fun titles. Well, I think our audience has heard of MetaGeek forever. You just wanted to give a quick recap of the last, decade or however long you've been doing this.
Sure. We've actually been going 14 years, so I don't know if we're still a startup or not. So at the beginning, it was just me, and I started out, my background was wireless mice and keyboards, which drifted me into making a poor man's spectrum analyzer, which was Wi-Spy. Launched that at the end of 2005, and then in 2006, I quit my day job and went full-time into Wi-Spy and MetaGeek, and the company's just sort of organically evolved since then. So we are a self-funded company and focus on how to make Wi-Fi better.
So let's just back up a little bit. From the first Wi-Spy, what was, what kind of go back to history? I don't think everyone who wasn't around the original Tech Field Day learned how you made that and what the base product was. And then, move up through the different hardware platforms you're using for your spectrum.
In 2005, I was doing wireless mice and keyboards. I was doing the wireless part for it, and Wi-Fi kept interfering with the mouse. And so it was a big problem. How does the mouse know that there's some interference on its channel and to find a channel that's not in the middle of Wi-Fi? While I was doing that, I was using a giant HP spectrum analyzer. It was, $15,000 unit. It was very bulky and loud. And I was like, well, if I can figure out how to get the mouse to detect that there's interference using the spectrum analyzer, can I just turn the mouse dongle into a little spectrum analyzer? And I have a master's degree in computer science, and I tinkered with some web stuff. And so I ended up doing the website, the firmware, the software. I went to a company that was doing reference design for the mouse dongle and had them build me a couple hundred units.
And this was the receiver for the mouse dongle, right?
Yeah, this was the receiver for the mouse dongle. And I just used its little RSSI part in the chip to basically say, hey, what's the signal strength? And the very first software was really, really crude and basic, and it looks like a 1980s video game. But it worked. And at the time, the only other thing out there was really the Cognio Spectrum Expert, which is $3,000. And so the Wi-Spy came out at $99, and all of a sudden it's affordable to get some kind of spectrum visibility for Wi-Fi. So that it took off. And people loved it. For $100, you get some visibility into the spectrum and what's going on and why is Wi-Fi not working. And then 2007, we said, okay, well, that's nice to have some spectrum, but it'd be good if we had some Wi-Fi network information. And at the time, NetStumbler was out. It was the only Wi-Fi scanner available. It was free. It was closed source. And at the time, the developer had got a job at Google. He kind of quit working on it. It didn't work in Windows 64-bit, and there was some things with this was kind of lagging behind. So we said, well, why don't we do our own Wi-Fi scanner? We'll learn how to get some of this information, and then we can incorporate that into the Wi-Fi software. So that's when we came out with Insider. Another reason for Insider was I'm a geek. I'm not marketing. I'm not sales. And so how do we get more awareness? And so I said, well, let's use the development and coding skills to make a free app, which will build awareness and kind of be our marketing platform. And so then we took the Wi-Fi information from Insider and put it into the Wi-Spy software, which then we started calling Channelizer. Then, let's see. So the original Wi-Spy was 2.4 gigahertz only, and it was really poor resolution. And so we developed Wi-Spy 2.4X, which was an external antenna, 2.4 gigahertz only, and had a lot better resolution, so you could get a lot better idea of what was going on in the spectrum. with that, you could see not just that there's Wi-Fi, but you could start to see different signal patterns. And so you start to recognize, oh, that looks like a cordless phone, or that looks like a video camera.
So what was the hard? So you said that the first original $99 one was just a receiver from a mouse. Mm-hmm. What was the hardware on the second one?
The second one was custom designed hardware. It was pretty similar as far as the chip that we're using. So we've always tried to do pretty low cost hardware, as low cost as we could make it. And so it was still using a similar chip. The chip was made by Texas Instruments, and it's for like Zigbee and wireless stuff like that. It was just an off-the-shelf, basically Zigbee receiver, but we're only using the RSSI component of it. Then after the 2.4X, we had a lot of people saying, well, 802.11a is out now, and it's becoming more popular, so I really need 5 gigahertz. So we came out with the Wi-Fi DBX, which stands for dual band external antenna.
Oh, that's why the D's capital.
Yeah.
I never knew that. It's like, I whenever I typed it, it's like, it's got a big D. Dual band.
Yeah.
Okay.
We should have called it 5X or something, but we called it DBX.
DBX works.
Yeah. So that basically had a lot more custom hardware in there where we're down converting the 5 gigahertz signal into 2.4 gigahertz. So we can still use that off the shelf 2.4 gigahertz radio to do the RSSI measurement. And so that was 2000.
Oh, and that's why you can't have it like scan both. You can have it either 5 or 2.4. It can't do both at the same time.
Right. Exactly. Because we have to reuse that 2.4 gigahertz radio. And so with all of that, the software became much better. We added in more interference patterns. So you can start to see device patterns, and the software would try to automatically figure out what devices were in the spectrum. We also were getting a little bit more Wi-Fi information, but it was still just coming from the Wi-Fi scanner. And so we could get beacons and some basic information, but there's still a lot of information that we couldn't get about the Wi-Fi.
About that time, there was I think they were out of Hawaii. Someone wrote a Mac app that used a DBX for its input.
Yes.
So you open sourced or something the stream that came off of there? I just thought it was a pretty cool app at the time.
It was a pretty cool app. It was pretty cool. Yeah. So there's a few different people that were developers in different things that, hey, I want to use your hardware, but I don't do Windows. I do Mac or I do Linux. So we had the Mac one, and we basically said, okay, well, here's the USB API, and here's how it's working. Mike Kershaw, who does Kismet, also did Spec Tools, which is sort of like an open source version of Channelizer on Linux. Mike, and we gave him the USB API.
You mean Draghorn?
Yeah, Draghorn. We gave him the USB API, and the next day he had this command line interface going with, you could do a little spectrum analysis going in the command line terminal. It was very geeky and very cool. And so we've been pretty open through the years of different people using the hardware for various things. And we have some people using it in manufacturing. So they have their own custom manufacturing software that they're trying to use our Wi-Spy to go with their software to figure out whatever they're manufacturing, whether it's TV remotes and things like that.
Well, and then you moved on to more analysis. I think you're heading towards IPA.
Yeah, and so we started learning more about actual Wi-Fi data, and started using Wireshark, and realized Wireshark is nice if you know what you're doing, but it's pretty technical, and it's kind of hard to find the issue if you're not exactly sure what's wrong. And so then we started working on IPA, and IPA is our visual packet analysis tool.
And your reminder that you like beer.
Yes. Most of our code names internally are beer names. And when we came out with IPA, we quickly realized that we didn't know very much about Wi-Fi, actually. And that's when we had you, Keith. I think that's about the time that we met you and said, hey, Keith, will you come up to Boise and teach us all about Wi-Fi? And so that started our adventure into really learning about Wi-Fi and getting educated. Since then, we've had Robert Bartz come to Boise 3 or 4 times to give us training. And so we have a lot of people now that are CWNA, CWAP, CW.
Even your mom, right?
Yes, my mom was CWTS, I believe, and that's the lifetime certificate.
Yeah.
So she's still proud that she's Wi-Fi certified. Yeah. So I think I'm probably the only chief geek whose mom is also Wi-Fi certified. On
both accounts, you're the only chief geek and the only one.
Yes.
Probably the only one in the whole community also has a mom that's certified. So
yes.
That counts.
Yeah. We did IPA, and then that started us on the adventure of learning a lot more about Wi-Fi. And we realized that packets are very important. There's a lot of information in the packets that you can't get any other way. And at the time, the only way we could get the packets on Windows was using the AirPCAP NX from Riverbed.
It was only $800.
Yeah, it's only $800. And so it's like, well, that's really accessible to everybody. So IPA worked fine. IPA was a pretty complicated, but it was a pretty expert tool. And the air pickup index cost $800, so it kind of fit. But that didn't allow us to bring packets sort of to the masses. About 2 years ago, we started conversations with Tamasoft, who has some Windows drivers for some Realtek adapters. And so we licensed their drivers, and now we're able to get packet capture on Windows for a lot more reasonable price, because the Realtek adapters cost anywhere from about $30 to about $100. There's a variety of TP-Link, D-Link, Linksys.
They'll use that same driver, yeah.
Yeah, they'll all use the same chipsets. And so now we can work with a variety of those. Some are really tiny 2x2 adapters that just stick out of your laptop about 1/4 inch. Some are really big, beefy 3x3 adapters with 5 dBi antennas on them. And so now there's a variety and fairly low price points. And so we can get packets accessible to everybody. So that's what we're excited about now, and kind of where we're going, and what we just showed at Mobility Field Day 4.
Well, that's got new hardware to go. That's new hardware as well.
That will lead to client traffic analysis. We also really want to do more mobile stuff, because mobile is becoming very important. A lot of people don't want to haul their laptop around. Laptops are kind of big and bulky, and cell phones are becoming fairly capable these days. And so we also have been partnering with Osseum, and we just released the Wi-Fi Air, which uses Osseum hardware, but it also has some basic packet capture in there. And so now we have Spectrum and some basic packet information on mobile, both on Android and iOS.
But to do that, you had to take theirs is Spectrum only. So how are you getting the Wi-Fi data?
Magic.
That's always good. We
Yes.
like using Magic.
The Wi-Fi Air and their new Wi-Pri have custom hardware, and we currently have exclusive on the packet feature. So that's how we're able to do it.
Oh, okay. And that's your hardware?
They're designed on the hardware, but they designed that specifically for us.
Oh, okay. But it's your software that's peeling off the packet information.
Yes. So it's all our software that's peeling off packet information and crunching in, trying to say, well, here's your clients, and here's when they roamed, and here's what's going on.
Okay. So you have from a hardware standpoint, you have you're still selling the DBX, well, the DBXs and the 24Xs?
We still have the Wi-Fi DBX for Windows, and then we have the Wi-Fi Air for iOS and Android.
Oh, okay. So the old 2.4 only ones are kind of EOL'd.
Yeah, they're basically EOL'd. We weren't selling that many of them at the end. Most people have dual band networks, and so let's get the tool that will check both bands.
And if you want both bands, just get 2 of them.
Yeah.
I have 2 in my bag all the time, just for that very reason. You also had a little antenna for a while. Is that still a thing?
Yeah, we did have a directional antenna. They were at the time, there weren't any directional antennas that really helped to do any location, and so we custom developed our own. Since then, there's some cheap off-the-shelf ones from Alpha, and so we decided to not continue making ours, because we could honestly buy the Alpha on Amazon cheaper than we could make one ourselves.
That's one of those little light bulb moments. Like, oh, well, we ought to probably just buy that one.
Yeah. So now our hardware lineup is basically Wi-Fi DBX and the Wi-Fi Air, and then we also resell a couple of the Wi-Fi adapters to work with IPA.
And just to make it ease of use. So
exactly. Some people, it's like, I have budget and I want to do one purchase, and I don't have to do a bunch of different purchases, so I'll just buy it from you. And we just mark it up a little bit from our price off CDW or Amazon, wherever we buy it now, and sell back to you. So we're not really making money on them. It's basically just convenience for the customer.
Just to make it easier. And so then the software is the Wi-Fi Air software on the iOS and Android, Channelizer, and IPA.
Yes, and then also Insider.
Oh yes, and yeah, we forgot so Insider was free.
Yep, Insider was free,
and then you sold it for a price, and then now you have multiple Insiders.
Yes. So Insider has had an interesting history. It started out open source, and then after a couple of versions, we closed sourced it. It was free. Then we started charging $20, and then we also had a higher end version that was $100 called Insider Office. And now we've sort of shifted a little bit, and Insider itself is free. We're working on a subscription layer that enhances Insider and also enhances AirViewer, called the cloud part is called Rampart. The subscriptions are called MetaGeek Plus. And so if you go to our website, there's a section on MetaGeek Plus, which is a subscription that pulls in the data from the different applications all together. And it's pretty exciting because in the past, our apps were very much sort of like the real-time troubleshooting, but I have no history of what did this network look like last week or the week before, that. So it's really hard to troubleshoot if you don't know what's changed when it worked. There's no baseline. And so also the tools weren't aware of any of your other colleagues. So if you're on a team and somebody else from your team was at the site last week and now you're there troubleshooting, there's no awareness of of anything but the network between your colleagues. And so with our new subscriptions, we're trying to tie all that together between different teammates and also the history of the network over time. And so we can start to say, oh, this and this changed. You have more neighbors. The neighbors are getting more talkative, and a much better idea of what the network looked like when it was working great and what it looks like now when there's a problem. Or it looks like there's a trend going towards a problem. The channel utilization is getting more and more and more, and soon this is going to be a problem. And so we can sort of proactively help our customers keep their Wi-Fi running, keep it running smoothly before there's a real problem.
So how do you show the differential? Is it like from 2 weeks ago to today? How would I look at that to see the differential between the 2 days?
Mm-hmm. We're just getting some of those views. I think some of that was deployed yesterday, where now if you go in and you look at a snapshot of your network, say that's taken yesterday, it'll also show you a bar chart over all the snapshots that you've taken of the signal strength of each AP and also the utilization on the channel. And so you can kind of see the utilization, how it's going. It'll also show you, if you have information about number of clients, how that's changed over time. And as we get into that, information is just coming from the Wi-Fi scanner portion. And as we get into that packet capture in Insider, which I kind of alluded to earlier, we'll be able to get a lot more information about each network, each AP, what their airtime is taking, and also down to the clients, which clients are the top talkers, which clients might be having problems. And so all of that client information can all go up into the cloud as well. And so now we're getting context of all your clients and all your APs and all your neighbor APs. And all that's kind of going all together to say, oh, well, here's what's changed. Here's what could become a problem. Here are 3 steps to help you improve your network. So that's all kind of where we're going with it. So
right now, been through the little history of Insider. So right now, Insider's free. And it sounds like a lot more features than just the original Wi-Fi scanner. It's got more packet analysis. But to see the packet analysis, you need to have the cloud subscription?
Yes. So to get into the packet analysis, you need to have the cloud subscription. The base MetaGeek Plus subscription starts at $12 a month. So it's pretty accessible. And then currently we have a Plus, and we also have a Pro subscription level. The Pro adds in the teams. And so you have teams. You also have unlimited sites, unlimited rooms that you can take snapshots of. And coming soon with those 2 flavors of Plus and Pro, we will have the packet capture. And so if you plug in one of these Realtek adapters, you'll be able to get all the packet analysis. You'll be able to get client traffic analysis. So what's the utilization of each client? What are their capabilities as far as spatial streams, MCS index, that kind of information. And so I'll have a lot more insight into the clients and who's talking. And also currently in Insider, from the Wi-Fi scanner, you just know the channel's busy, but you don't know who's using it. The new client traffic analysis will also know who is using it, which network. Is it you? Is it your neighbors? Is it a specific client? We also have client signal strength over time, so it's easy to track down clients. So if you fire up the software and it says, oh, this one client is taking 20% of the airtime, you could click on the client and then go track down the signal strength and go right up and figure out who it is and what's going on.
Is there a way? It sounds like you've taken the drivers for those Realtek NICs and incorporated them into Insider so they can either run an internal NIC or the external NIC. And if you have the external NIC, then you can get the packet capture on the client side. Is there anything in your roadmap to take that to have the ability to have a remote IPA that someone else is out there and I have IPA, and so they say, yeah, the channel utilization is high, but I need to do even more detailed analysis?
That's a great question, and we're definitely moving in that direction. What we have so far that we've kind of done a proof of concept on is Insider with that packet capture being able to automatically trigger on an event, say a client roamed, we can automatically take that and save a little PCAP of right before and after. So say we get like 500 packets before and after that event, and we can save that in a little PCAP. Where we're going to go with that is that little PCAP can now go up to the cloud, and then you could get it then you can download it right into IPA. And so you can have somebody out in the field, a technician or somebody that's out there, they can capture the events. Insider will tell them when the event happens, like this client roamed, and that PCAP will automatically go up into the cloud. So that's kind of where we're going with that. And there's also some other ideas we're doodling on for like, how do we get some of that packet capture, the deeper information that the expert might need up in the cloud so the expert can use it.
And your cloud goes by the name Rampart.
Rampart, yes.
So the product that you buy is MetaGeek Plus?
Yes.
But the product name is Rampart.
So because the subscription ties into Insider, AirViewer, Rampart, potentially maybe even Challenger and IPA, we're still trying to figure out, how the different apps connect together. We decided that we needed a more overarching subscription name, kind of like Adobe Creative Cloud. So kind of go with the overarching name of just MetaGeek Plus. So
Rampart is the cloud, and the MetaGeek Plus is a subscription to the cloud.
Yes.
Okay. Just trying to get, I'm sitting looking at it going like, now which part's which?
Yes.
So MetaGeek Plus is the subscription. Rampart's just the cloud version. And so of all your current products, between the Weiss by Air, Channelizer, IPA, Insider, which of those talk to Rampart? So currently AirViewer and Insider talk to Rampart. And then we're working on what data do we do from Challenger and from IPA? As you know, PCAP files can get really large really fast. And so we're trying to figure out, what do we do there? Do we just upload everything? Is there sort of this integration between small PCAP files from Insider that you can then automatically open in IPA? And kind of how do we go about that? And then on the Challenger side, trying to figure out like, how does all this information hook together with the Spectrum? So both of those, we're looking for feedback from users about, do you need Challenger into the cloud? What would that look like? What are you trying to do with it? What's your scenario? And so if you have any feedback on that, Adam I was really interested in talking to you. And his email address is just adam@metageek.com, ADAM. And he would love to chat with you about what would you do if Challenger or IPA was hooked into the cloud. I think that's a good thing if anybody wants to play that. I think the remote access, a lot of people are going this less expensive hands in the field, but you still have to have the more advanced, analysis back centralized is a good process to look at that workflow to allow you to not have to be on a plane nearly as much. Yeah, I agree. And I'm personally fascinated with like Raspberry Pi, WLAN Pi. These little tiny computers are getting more and more powerful. And now with Raspberry Pi 4 having, built-in H11 AC dual band, it's looking pretty cool. And so if we can take some of the functionality of what we're building into Insider and then say, can we put this in a little tiny box too? I think it's definitely something we're going to look into soon. And so we'll kind of see where that goes. We haven't started anything yet, but it's definitely something that we're interested in doing. I mean, you said you've been around 14 years doing development. You moved from, not totally moved, but you've added, in addition to client software on iOS and Android, that's, very lightweight smartphone. You have Mac products. You have Insider for Mac. The other products all run on Windows. How tough was the transition from being a developer on local platforms to being a developer for cloud? So I personally am still a developer on local. We do have a couple great engineers that are good cloud engineers and that have that background. And so we've sort of been bringing in different people and also building up our own skills. MetaGeek is very much about learning and growing and developing your own skills. And so we've had a lot of people that have just kind of built those skills. We're kind of new with the cloud game still. And so that will evolve a lot over the next year as we kind of learn more skills and get the basic foundation stronger. I mean, are the concepts the same? I mean, not being a developer, I just didn't know how much extra effort it was to have something that was cloud-based rather than having local control. The concepts are pretty much the same. Now there's definitely more complexity in the overall system because you have the desktop software. The data has to go up into the cloud. So there's a different piece there that processes the data, gets in the database in the cloud. And then there's sort of the front end of the cloud. And so there's now 3 pieces that all have to work together. And so just the overall complexity of the system is a lot higher. But when you get down to developing any one piece, it's pretty similar. Using the same formats. So however you saved a Channelizer format is the same format that could be up in the cloud? Yeah, we could definitely just bring up PCAPs or
WSX files straight in the cloud. A lot of the stuff we're doing right now is all going up to and from with JSON, which is a pretty standard format for sending data to and from the cloud.
That's why I have you on these, so I can learn all these new things.
Maybe we need a WLPC talk about some of this stuff.
Yeah, I think so. I think people are interested in knowing not just what's happening, but kind of how. And your story from the first time I met you, we were at it was WTF, it was Wireless Tech Field Day, and you showed pictures of your Lego mouse mover. I'm like, oh, I like this guy. He used techniques.
That's right. And we just brought back some of those Legos from Mobility Field Day with the little MetaGeek logos in Lego kit.
Yeah, didn't your daughter design that?
Yes, she did. She was pretty excited for that.
And I've got it sitting here on my desk, a little MetaGeek logo in Lego.
Awesome.
You got to use Lego.
Yeah.
Well, what's next for MetaGeek?
The next big thing is really the packets in Insider and how do we do the client traffic analysis. And that's going to be a big push because there's just so much more insight we can get from all the packets. And especially if we can get packets, little snapshots over time, we can process that all in the cloud and give you a lot more insight into how we can improve your network. And then after that, we're also looking at, like I mentioned, what do we do with challenge and IPA? How do they hook into the cloud? And how do we integrate the whole system together? So there's a lot of that. And then we're also looking at, we've had, so many requests for IPA on Mac and different things on Mac. And so we're like, how do we up our Mac game and get it much more consistent with the Windows versions? Right now, the Windows versions are way ahead of the Mac. And so how do we do that with a small team? Well,
you made me get excited there for a minute until you said, and then how do we do it with a small team? Like, IPA on a Mac would make my life so much easier.
Yeah.
But I'm sure I'm the first person ever to ask for it.
Right.
Plus, you wouldn't have to worry about all of those unique drivers. The Mac just goes and sucks them down automatically.
Yes. And that part is pretty cool. Since we've been doing more of this packet capture with the Realtek adapters on Windows, looking at the Mac, it's like, well, it's already built in. We don't need to ship you any hardware. You just download the software and you're good to go. So that is pretty appealing.
And Weiss by Air, what's the future hold for that?
The future for Weiss by Air holds there's more data that we're getting that we're not really processing or doing anything with because we're getting all the packets. And so how do we present more of that data more meaningfully? And so, yeah, I think you'll see some of the new stuff that's coming out in Insider get ported over to Weiss by Air and the Air Viewer. And so it'll get a little more capability there. We just released, I think last week, the network snapshots ability in Air Viewer. And so now we can send data to and from the cloud. And so we'll get a lot more of that capability as well. We're also looking at with Weiss by Air, getting drivers to work on Windows. And so if you have a Weiss by Air, you can plug it into your Windows or your Mac if Channelizer was there in a newer Channelizer. So how do we take that hardware that you bought that is fairly expensive, it's about $1,000, to work on any platform that you have?
So a DBX versus the Oscium spec end that you're now using this Weiss by Air, is that an option for someone to buy that instead and just plug it into USB port?
Yeah, so that's what we're trying to work on is can we just have it be more an upgrade? Because right now, if you wanted to do mobile and laptop, you have to buy both analyzers. And it would be better if you could just buy one of them. And because the Weiss by Air also has some packet information, that makes it pretty compelling. And so we'd rather just sell the Weiss by Air and just have everybody be able to do, spectrum analysis on their laptop and also on mobile. And now on mobile, also get some packet information.
One final question. It's kind of a silly question. All of your products have the same kind of 3/4 circle plus a little corner on the bottom. What's the genesis of that?
We did a branding exercise in 2013 and settled on that as kind of cool and unique. And so we said, let's use this as the base for all of our logos. I can't remember exactly why we said this shape, but at the time it wasn't really being used by anybody and it seemed pretty simple and clean. So we went with that.
No, I like it. And
thank you.
Well, thanks for your time today, Ryan. I hope you can get back to your work now. And thanks for sharing with our audience.
Awesome.
And
thank you, Keith.
We will see you on the net.
10 Talks.
All right. So, Colleen Szymanik. Joining me on the stage also is Firash Shari. We work for new hardware certification for Comcast. And we wanted to kind of share a little bit of our experience of the last year. We started testing all the different chipsets that support 11AX. And we kind of wanted to walk through our process and a little bit about our journey and some of the things we learned so we could share with you. Hopefully we can get a lot of these issues and interop things that we're seeing fixed sooner than later. So we've been hearing a trend about a lot of data, right? So the data that I collected is, where do you start when you try to boil the ocean with something like this? So we look at the popular applications that are on our network. Anyone want to take a guess or fathom what number one is on our Netflix, right? So I don't actually have a breakdown of streaming versus downloaded or anything like that, but that's number one. Second, YouTube. Thank you, YouTube. The interesting stat that I learned from that one was that half of the YouTube traffic is not just the TCP traffic, it's quick, right? So UDP matters, right? So as I'm trying to build in my head what I'm modeling, what environments I'm setting up, I'm looking at that like, well, I should have a lot of, obviously DNS, is on there, much further down, smaller packets, very just small transactional stuff. But, UDP will be important for us to test and make sure we know that it works well and works concurrently, right? So that's interesting. There's, obviously a lot of video traffic. We're a service provider and a cable company. Clients. So a very popular fruit company. Is probably the majority of the popular clients that are out there. Some of the other statistics, so it's not very, very surprising or very fun, but some of the other statistics that we started building our environment on that I think is kind of interesting is the concurrency, right? Because the charter of 11AX is the high density, right? So how many concurrent devices are connected in a typical home? Now this audience would not be what I'd model, right? Because most likely not everyone's home is going to look like the homes that most of us have, right? So the interesting stat is that I get about 10, 11 devices in like the 85 percentile that are concurrently connected, about 4 on 2.4 and about 6 or 7 that are on 5 gigahertz. Okay, so that gives me somewhere to start. One of the other statistics that I find interesting that I've actually been following for a while is I have some telemetry data out there that actually gives me the interesting distribution of what the packet sizes are out there. So while the majority of traffic is in the 1500 byte packet range, the amount of small packets that are on our network has done nothing but grow in the last 3 or 4 years, which I find interesting. So it went from about 27%, which I thought was a pretty high number to begin with, in that 64 to 127 byte packet range, to 39%. That is crazy. And usually we don't market or we don't manage that kind of stuff. But that's something where I'm like, wow. So now I'm going to have high efficiency. And what's the charter? It's supposed to help that bottom 10%, right? So those small packets, take those resource units. Interesting. So I'm setting myself up probably for disappointment of expectations, but I like to think we have an environment that might really kind of play well for this new technology. So, of course, we also have to state what we want, right? So we wrote a technical requirement document. We put a whole bunch of, table stakes in there about what's supported today, some thresholds on, service and how many devices are connected, what kind of service level we're looking at, what kind of bandwidth requirements we need, as well as, little things like OFDMA, uplink and downlink. Some of the differences that we see with that, actually, I think that's more interesting are the fact that some vendors or chipsets only support 4, some support 8. Some support 32 concurrently OFDMA. Have I tested that yet? No, I have not. But trust but verify, right? So if it's there, I think eventually it will come along the way. But it's something that I think is interesting that there's differences, right? So actually, my deep dive, which I love so far, is on the API side of things. And one of my instructors said yesterday that all the interesting things are happening in software. And as hardware engineers right now, I will say, yes, there are a lot of interesting things happening in software. But if you have poor hardware, your software is not necessarily going to fix that poor hardware, right? So we're going to get this right. We're going to do as best we can, right? So how am I setting up the test and what are we doing? All right. Oh, I'm running low. Okay. So we have the popular clients, the popular applications. We have the turntables. We have all the things that basically we normalize power, we normalize antennas. We kind of just set everything up to say, okay, this is the same as we could possibly make it. Throw the same traffic at it. Let's see what the differences are. All right. So we get some charts and some charts and some charts and some charts and charts and charts and charts and charts and charts. Okay. What does that tell us? Well, some are better at one thing and better at others, so it doesn't really help. And I must say, and I will turn this over to Stu, I must say that one of the things that I really hated for the longest time was the fact that people would measure success from just bandwidth. Well, I don't care necessarily about bandwidth. If I'm not being asked for, a gig of traffic, doesn't mean my network's failing. It's okay, right? I should be able to serve what I'm asked for. How do I do that intelligently? But over the course of the last year, I've had a lot of conversations with a lot of QA and chipset vendors and stuff. And they actually brought up the best scenario that I thought that actually justifies this in my head for being okay, which is bandwidth is the canary that sings, right? So it's not going to exactly tell you that there's something wrong or that there's what the problem is or that it's failing. But if you get a dip or something happens, it's singing, and you better go and dig and have the right tools and telemetry and everything set up that basically shows you what's going on. So you dig, and we dug here, and one of the things that we found was that this client was dropping, so the bandwidth was going down pretty poorly. This is a cumulative distribution function. And we weren't getting any MPDUs. We did some packet captures and stuff. Turns out that there's an interrupt problem with MFP. So earlier today, we heard from OWE and SAE that MFP is mandatory, right? Well, it's mandatory, of course, for the Wi-Fi certification, but doesn't mean it's going to come out enabled, and it doesn't mean that it's going to work, right? So these are the trials and tribulations that we're going through. Let's talk through a couple more of them.
To go through this really quick. So basically what we see here is actually the endurance test. So like what Colleen said is throughput tests are not the goal, they're the mean for to get to the hidden issues with. So what we see here is actually an A/B under endurance test in which we were pushing 900 almost to the theoretical level, 900 Mbps on the uplink. The client was 3x3 80 megahertz VHD, and for some reason that we collected the logs and the data and sent back to the vendor, but for some reason the AB will continue working fine until a certain point in time when you see the drop between the offered load and the what is actually received. And the interesting thing that we saw here is basically that the AP you lose all connectivity to the AB at that point. So you can't SSH into it, you can't telnet, you can't log on to the GUI. You basically the AB it's frozen, and won't go back to the original to a normal state until you stop the load. We're not sure what's going on, and we sent everything back to the vendor, but if I would take an educated guess, I would say it's not a Wi-Fi issue. It's more of something eating up the processing power on this thing. The thing is our testing is not only about Wi-Fi. We're not looking at getting the best chipset only, but we're looking at a whole solution that will be integrated in in our next product. So, okay. And so, it's very hard to test something without having the right tools for it. And we don't have any clients for X. We don't have any, any tools to look at the package. So what we can look at it. So what we come up with is the beacon. Everyone can look at the beacon, even an A client can look at the beacon. So what we did is actually we captured the beacon for different clients, for different ABs, and we basically run analysis for it. So we looked at what is supported from hardware perspective, what is supported from on a roadmap, from software perspective, what the vendor is not interested in supporting. And actually one of the interesting things we found are some of the features that those ABs were advertising, they were advertising incorrectly. So if you, I'm not sure if it's clear, but some of the green fields with the S in them, they have a little star on them. So basically, those means whenever you see those stars, means that we actually saw that the AB was incorrectly advertising this this feature or this element. And when we actually faced a problem with it, with on a certain AB on VHT, no matter what we did, we couldn't get the client to connect to 160. I know you guys hate 160, but bear with me here. So 160 short guard interval. So no matter what we did, we put them in a clean environment and nothing worked. And then when I was surprised, we went back and we saw actually the AB was advertising that it does not support this short guard interval, even though it did, and the vendor said it does. One of the other things that we saw, that we concluded through the throughput testing is actually small packet aggregation rate. So around 45% of the traffic on our network is small packets. So it's very important for us to have an AP that is capable of aggregating high volume of packets on the, with the small sizes. So this plays a lot in our decision choosing what solution. If you can see at a certain point, the throughput is capped by the Ethernet because we're running traffic, a downlink from the Ethernet to the Wi-Fi. So we're capped at 900 something. This is where all the if you can see all the columns just almost they have the same value because of the Ethernet restriction. We had to include a heat map here. Everybody loves heat maps. So some of the vendors actually claim that even with the new AX, we will see an improved VHT performance around 10%. And we were trying to quantify this, this improvement. So what we did is actually we took the new APs with the AX and compared them, to our old solutions that we have deployed in the field. And we run some, our home test solutions, we run some site surveys, to get RSSIs, to get uplink and downlink throughput. To be fair, we saw an increase, but nothing that we can actually see on user experience. It didn't really show much of an improvement when it comes to the user experience, but from an abstract point of view, yes, it did. You can see that the new chipsets had better performance when it comes to VHD. This is a very, very interesting case we had where the actual AB had only an issue with a single client, 80 megahertz VHD client. It will work fine with any type of client, but if you specifically connect a client with that, one spatial stream, 80 megahertz VHD, around the vicinity of minus 57 dBm, you will see a spike in the packet error rate. And for some reason, we still don't know what's causing it and what's the issue. We're trying to figure out what it is. This is coming from one of our, from distinguished engineers, Dave Urban, and we were talking about it, and he was thinking that it could be a problem with the LNA, the low noise amplifier. So basically, what you have here, when you have an input, to the an input signal, there is a point where the signal drops under a certain threshold, where instead of bypassing the low input, the low noise amplifier, you go through it. And from his experience, he thinks that this could be an issue with transitioning from that, transitioning from bypassing the amplifier to going through the amplifier. That could be the issue. We still don't know. We're looking at it and collecting the data and send it to the vendor. Other tests we're doing is the RF testing. We use the XCA chambers. We're very wave. So we look at if the AB is complying with FCC. But we don't really we think vendors do a really good job on this, but we just make sure we look at those stuff just to double check. We look at the spectrum mask. We look at the of course EVM is very important for us. It's a part of our TRD, so we look at that. We look at the constellations in all different MCS rates. So We also look at what's called spectral flatness. Excuse me. So this is an interesting case where you can see this is a 3x3 spatial 3x3 I think VHT 80 megahertz. Yeah, it's 80 megahertz. So if you can see here, like on antenna A, like the AB passes the spectral flatness test, but it doesn't actually do that in antenna B, and C. Like you can see little spikes going outside the borders here. This is where the limit is, because you have like the average between the difference between the average power and the power for each subcarrier on the off-DM should be around 4 dBm plus or minus, and then 6 dBm at the end. So like actually in this case, it kind of like, it passes that important lessons that of things we learned from here, like test with the AB with every single device you can put your hands on, because like you never know which one of them will trigger, an issue with the AB. RF testing is very important, making sure that like the physical layer is solid before like going to the MAC layer. That's very important. And thank you. Sorry, I mean, we're already way behind our time. Thank you.
We're going over. Thanks, guys.
Thank you for joining us for another episode of the Wireless LAN Professionals Podcast, the podcast for wireless LAN professionals by wireless LAN professionals. Be sure to follow us on Twitter @WirelessLANPros for all the latest news and updates, and also connect directly with Keith on Twitter @KeithRParsons. Head over to www.wlanpros.com for this episode's show notes, as well as the latest in all things Wi-Fi.